Welcome to Girls Who Maths. I'm Libby. You'll meet Alex in the next set of videos. Today I'm going to go through the AQA higher paper from 2019, that's paper 1. In the next set of videos, Alex will go through paper 2 with you. So let's get started. Question 17 now, it's quite a wordy one and I've done that on purpose. So the question says, Toby is forming and solving equations. The product of half a number and 3 more than the number is the same as the square of the number, and Toby uses y to represent the number. Write an equation that Toby could form. So they've purposely written even the numbers out as words because it can be quite overwhelming, so it really requires you to actually nitpick out every little detail so you can form that equation. So that's what we're going to do now. So let's start with the first bit. The product, so that's multiplication, you times in two factors together, so the product of half of a number, that number we know as y, so half a number, and we're timesing that by 3 more than the number, so we're timesing it by 3 more than the number, so the number plus 3 is the same as, so we equal it to the square of the number, y squared. Write an equation Toby could form. There we go, we've done it. So all this question is about is just picking out that important bits of information. So knowing that the product is them times together and things. Don't try and solve it. The question doesn't ask for that. It just wants the basic equation, and that's what we have here. The next part to 17b says Toby forms another equation. X equals 9 over 8x. He wants to work out the values of x. Here's his working. And what error has he made in his working? So this is a bit of a wordy question. It wants us to explain where he's gone wrong. So the best way to do this is work through it like you would. If you were solving this equation, how would you do it? Right, you're starting with this. He's moved the ax across, which is made ax squared. Absolutely fine, that's what we would do. Now, to get to the next line down, he's got rid of the square, and 9 has gone through, which means he's square rooted the equation. However, we know that when we square root an equation, you have to square root everything. You have to divide the whole thing by the square root. You have to square root it all. He square rooted the 9, fine. He square rooted the x squared, but that 8x is still there, which means he hasn't square rooted the 8. He hasn't square rooted the 8. And all it wants is that 1 mark answer of what you spotted as a mistake. So we've spotted that mistake, so that's our 1 mark answer. On to question 18 now. So 18 says here's an identity. 8x squared minus y squared. 3 equals lines means it's the same as. So that equation there is the same as x plus y in brackets and x minus y. Using the identity, work out the value of 193 squared, minus 7 squared, and you must show your workings. So it's important that you must show your workings. So let's use this identity. That's what it wants us to do to work out this. So this, well, it looks very similar to this, doesn't it? So what we can do is we can say that for our calculation, x is 93 and y is 7. Using this side of the equation, because it looks the same. Now, we know that that has to be the same as this, so we can put our x values in there. Minus 7. So what does that give us? This side of the equation is 293 add 7. Oops, that's 8 times 93 minus 7, which is 186. So that's what it wants us to work out, and that's quite a difficult multiplication. So what we can do is, well, we can do 2 times 186, and then we can add the zeros on afterwards. So if we do 186, I'm going to write it in this multiplication way just to make it a bit easier, and then we can work out each one. So we do 6 times 2, 12, carry the 1. 8 times 2 is 16. Remember, we've got that 1 from before, so we add that one, 17. 1 times 2 is 2, add that 1 that we've got carried there is 3. So 372 is the answer to this. Remember, we took them 2 zeros off before. So what we need to do is we need to add them back on for this one. So that is when you times it by 2, when you times it by 20, when you times it by 200. So the answer is 37,200. And that's how I would work it out. But again, you could do a multiplication method with the 200 here and do a long multiplication if that's what you'd prefer, but you will get the same answer. The next part of 18, so 18b, says factorise 100a squared minus 81b squared. And remember, it's part of this 18 question that gives us this identity. And factorise basically means put the brackets back in. So we want to get an answer in this form. Now, you may be thinking, oh, well, x equals 8 or x equals a, sorry, but that's not the case. We need the whole part of this side of the fraction, this side of the equation to equal x squared. So what we need is 100a squared must equal x squared. So what we have to do is square root the whole thing and that'll give us x. So if we square root 100, that's 10. We square root a squared, we get a. We can do the same for this 81b squared. So we square root the whole thing, 81 square root is 9. Square root the b squared, and that gives us y. So now we can put those two terms into this equation. So every time there's an x, we're putting 10a. Every time there's a b, we're putting a 9b. Oh, y, sorry, we're putting a 9b. There we go. That's our factorised equation. Question 19 now, it's another 1 marker. It wants us to circle a fraction that's equal to 0.1 with a little dot above, which is 0.1 recurring. So we can also recognise that as infinitively. It's recurring, so that one will go on forever. Okay. Gives us 4 different options here, and this is 1 marker, so it wants you to be quick. It wants you to quickly recognise rules and patterns. That means you can just rule things out. So let's look at 1 over 10. 1 over 10 is a simple decimal, and we write it as 0.1. There's no recurring or nothing, so it can't be that one. It's the same when we divide by 100. It's never recurring. We can split a decimal very easily by 100. It would look like that. So it's not that one. So that leaves us with this one or this one. Now, straight off the bat, 1 over 99 is a very small number. So it probably isn't going to be 0.111. It's probably 0.0111. But we'll work it out nonetheless just to make sure. So we're doing 1 and we're dividing it by 9. So 9's going to 1, they don't. But remember, we carry that 1 across. 9's into 10 is 1, and there's a remainder of 1. Again, you can see where this is going. 0.111. So it is the answer. But we will just do 1 over 99 to double check. So 99's into 1, 0. 99's into 10, none of them. 99's into 100, 1. So you can see it's not that one, there's an extra 0 in that one, which means it has to be 1 over 9. Question 20 now, so the minute you see a picture like this, you should be instantly thinking of what circle theorems can apply. So A, B and C are points on a circle, CD is a tangent, that's going to be important. Assume the triangle ABC is an isosceles triangle, 2 lines of the same length and 2 of the same angles, with AC equaling BC. So AC and BC, they're the same length. Prove that AB is parallel to DC. Okay, let's look at what we've got already and what we know. Well, an isosceles triangle means that it has 2 side lengths of the same, but also 2 angles. Now, because these lengths are the same side, it has to be these two bottom angles are going to be the same. So remember, when we're writing angles, we use the letter that's on the angle we want as the middle letter, and then the 2 joining letters as the first and last. So in this case, we want this angle here, so we're going to label that as BAC. And we're going to equal that to ABC. And that's that one there. That's the first rule we have. Now, let's think about what circle theorems apply here. So we can use something called the alternate segment theorem. Now this says that when we have one tangent and we have a chord, so that's a chord, it cuts through the circle but doesn't go through the centre of the circle, the angle in the other section, so in the other segment is equal to the angle formed by the chord and the tangent. So in this case, this is our tangent, this is our chord. This angle, which we will label as ACD, must equal the angle in the other segment. So in this case, that's ABC. Now, we already have an equation which includes that, so we can put these equal to each other. So we know now ACD equals BAC. Now, how does that help us? Well, if BAC is equal to ACD, it's the Z angle, which means that this angle here are the same, so those lines must be parallel. So this is enough writing to get the marks, but I will just add a little sentence on the bottom that says something like, because of those angles, opposite angles being the same, they must be parallel. Just something like that, just a little bit of an explanation, just so they fully understand what you mean, but this should get you the marks. Okay, the last part for question 20b says that in fact, triangle ABC is actually an equilateral. So equilateral, that means that all angles are the same. So this angle here is the same as the other angles that we labelled earlier. Tick 2 boxes for the statements that must be correct. Obviously yours will have boxes, mine don't, but you get the idea. AB is parallel to DC, AC bisects angle BCD, and AC bisects angle BAD. Okay, well in the first part of the question we worked out that this was parallel, so we know that that is true. So that is one of our ticks. And the next thing is to just work out which one of these is true. Okay, let's look at the first one. So AC, so that's this line here, bisects, which means it goes straight through the middle of the angle BCD. Well, we know these two angles are the same size, so it has to go straight through the middle, which means this one must be true, but we'll check the last one just to make sure. AC bisects angle BAD. We don't know any information about this angle, we don't know what size it is, it's not going to be the same as that, we have no reason to believe it will be, so therefore that one cannot be true. So the answers are the first two, and that is because of the alternate segment theorem and the equilateral triangle. Question 21 now, it's a simultaneous equation. So it wants us to solve the simultaneous equations 2x plus 3y equals 5p and y equals 2x plus p, where p is a constant. And give your answers in the terms of p in their simplest form. So make sure p is in our answer and their simplest form. Okay, so it's been quite nice to us, it's given us simultaneous equations where we can straight away plug this second one, which is equal to y, straight into the first one. So let's do that. We know that y equals 2x plus p, so we put that in place of the y in the first equation and write that out. Now let's times out this bracket to get all our terms in their simplest forms. So 3 times 2x is 6x, 3 times p, and 5. Right, now let's cancel terms, so we can move the 3p across, we subtract that from the 5p and we get 2p. Then on this side we've got 2 and 6x, so that gives us 8x. So if we move that across, we divide by that 8, we get that. But remember, simplest form, that's not its simplest form. We can divide that again by 2, which gives us 1p over 8, which really equal, sorry, not 8, 1p over 4, which equals p over 4. So that's x. Now we've got x, we can plug that into this equation to get us y. So we use that equation because it's the simplest, but you can plug it into the top one and you would still get the same answer. So 2x, it's 2 times this one we just got here, which is p over 4, plus p. So now we need to solve this to get y. Okay, well 2 over 4 is equal to a half, so that gives us p over 2 plus p. Now we want this in its simplest form, so we need to combine those p's, so we just have one term, and that one term is really, it's a half plus 1, so it's 3 over 2p. The answers are a quarter p for x and y equals 3 over 2p. So that's your final answers, and they're in their simplest forms. Question 22 gives us two triangles, and it says that they are triangles ABC and ACD. Okay, it's a constant, we don't need to worry about that, it's just consistent through all the times you use it, it's just like a number. So it wants us to show that c to d is equal to 6a plus 4.5b. Okay, so c to d is this line here. Now, the way to do this is to look at how we can get to that line, because we don't know it. So we need to use the information that has been given to us to see how we can get there. So we can get there by going c to b, then b to a, we know that. Oops, that's a plus, sorry. B to a. And then we can go down a to d. That's going to give us the length of the direction. So, how are we going to get from here to here? Because this is an unknown. We know b to a is k, and we know a to d is 6a plus 7.5b. And now, because it's a show, we need to make sure that we've made it very clear what our answer is. So, b to c we can work out, because if you follow the direction of the arrows, it goes in that direction, which means it goes from b to c. So we know that that is ka plus 3b. So just to reiterate that point, if you're going from one point to the other and the arrows follow the same direction, starts at b and ends at c, then that is the length of b to c. But what we want is c to b. So c to b, we're going in the opposite direction, so we do the opposite, so we minus those. So now we can put this in our equation that we've already worked out to give us what c to d is. So remember, going that way, we've now gone from c to b, we know that. We already know b to a, and we know a to d. So now we just need to cancel things out and to get it into simplified form, and hopefully it will equal that one. K is, they can cancel, opposite signs, it doesn't matter. Right, now the only term we have is 6a, that's the only a term we have, so that's going to have to stay. But we have a minus 3 and a plus 7.5b, so we can cancel that out. So it's 7.5 minus 3, 4.5b, which equals the question, and we have shown that through the multiple steps, and therefore that'll get us the marks. Okay, we're on to 22b now, and we've got a little bit more information, and that BCD is now a straight line. We want to work out the value of k. You must show your workings. Okay, well, even if you couldn't do 22a, it gave us some information. It gave us that CD is 6a plus 400b. The other part of the straight line is b to c. We worked that out earlier as well, and we now know that that is that. So, for these two lines to be the same, there is a scaling. So this one will be scaled to make this one, or vice versa. One will be bigger than the other, but there will be a scale factor of the same. So let's look at this one. Well, we know these b terms must equal. This one must be a percentage of this one, or vice versa. There's a scale factor. So let's work out what that scale factor, oops, getting ahead of myself now, what that scale factor is. It's 1.5. So once we know that that is 1.5, what we can do is we can plug that in and say, well, these are scaled. Sorry, this doesn't equal b. The scale factor equals 1.5. So if we know that these b terms are scaled by 1.5, so to get from BC to CD, you have to times the length by 1.5, then this must surely be the same for this. To get from Ka to 6a, you've got to times it by 1.5. So what we can do is we can say, well, if we're timesing this one, the k, by 1.5, that'll get us to 6 because they're scaled by the same amount. Okay, so then we can simply divide that by 1.5. And that, if you've mentioned before, is the same as timesing by 2/3, which gets us 4. So that is doing by scale factor, by way of saying that one is a scale of the other because they're along a straight line. There are some other ways to do that, and if you look in the mark scheme, that'll give you a couple of different ways to do it if you find an easy way.